Welcome. In this video, we are going to go over four sequences, and we're going to determine which are geometric. If a sequence turns out to be geometric, we will find its common ratio and the next three terms. So let's begin here. In order to find the common ratio, we want to take a term and divide it by its predecessor. And so let's look at the first term. There is no previous term, so let's skip it and begin with a sub 2. So we're going to look at a sub 2 and divide it by its predecessor, which is a sub 1. So this is 3 over 5 divided by 3. That's 3 over 5 times 1/3, or just 1/5. Okay, so now let's begin with the third term, and this time we divide it by its previous term, which is the second term. So that is, we're dividing the third term here by the second term here. Take a moment and see if you can figure out what that is. All right, you should have gotten 1 over 5 again. And then let's look at one more. So the fourth term divided by the third term. And I'm already very suspicious. This is clearly going to be geometric, but let's see if the pattern continues here. So that is, we have 3 over 125 divided by 3 over 25. And that's also going to give us 1/5. So this is indeed geometric. So this first thing we identified here is that this is a geometric series. Now what about the common ratio and the next three terms? Well, the common ratio is fairly easy. The common ratio is 1/5. So this is the second part of this. Now, I didn't ask for this, but we're going to need it to find the next three terms. We're going to need its first term, so its initial term. And that's just right here, 3. So what will the next term be? Before we jump right into that, let's think of this one. This one has our initial term a, but we don't see a 1/5 times here. Basically, you can imagine this is a 1/5 to the 0 power, since this here is just 3 times 1, and that equals 3. Well, 1/5 again to the 0 power equal 1. So this one here is 3 times 1/5 to the 1 power, our second term. Our third term has a 5 squared in the denominator, our third term a 5 cubed, so clearly this term, our fifth term, is going to be 3 over 5 to the 5 minus 1 power, so that's 3 over 5 to the 4th power, and that's 3 over 625. I'm running out of space, so I need to resize this. Our sixth term will be 3 over 5 to the 6 minus 1, so that's 3 to the, 3 divided by 5 to the 5th power, and that's 3 over 3,125. And then our seventh term continues in a similar pattern, and that'll give me 3 over 15,625. Okay, so let's try it for the next three sequences. So pause your video and here divide A2 by A1, A3 by A2, and A4 by A3. So take a moment, pause your video, and try this. You should have gotten these three values, and as you notice, none of them match, so this is definitely not geometric. Now for the next two, I'm not going to show as much work as I did for the first two, so you'll have to determine if this is geometric, then you'll have to find the common ratio. You'll also have to write out the initial term, and again, this is only if they're geometric, and then find the next three terms of the sequence. So please pause your video and try that. All right, please go ahead and verify your work here. These are both geometric series, as you can see, with a common ratio of 2 here, of -3 here. That is, every step we multiply 2 for this one. And here for every next term, we multiply by -3. Both of these sequences have initial value of 2. And then the 5th, 6th, and 7th terms are given for this sequence, and the 6th, 7th, and 8th are given here. I hope you found this video helpful.